Okay. So should I start over?
Just do like a really quick recap.
Okay, so basically these three conditions must be met before we can use integral test. Okay, your A sub n, your sequence rule inside this sigma, has to be continuous, positive, and decreasing. And then we have to state what A sub n is and state that A sub n equals f of x, because now we're going to take that improper integral, and whatever happens here, if it converges, then so does this. If this diverges, then so does this. They behave the same way. Okay? Awesome. So we're doing this one first, even though we could use p-series. That would be a lot easier. But we're going to practice integral test. And we're going to see how this comes up as divergent. Okay? So I'm going to take the limit as b goes to infinity of the integral from 1 to b of 1 over x dx. You don't get rid of that limit until you have put that b into your f at b minus f at a. Okay? Don't drop your limb notation. All right, so what's the integral of 1 over x? ln, absolute value of x, and you're evaluating that from 1 to b, equals limit as b goes to infinity of ln of b minus ln of 1. Now you can drop your limb. So this would be ln infinity minus ln of 1 is 0. So then this basically is infinity, even though ln is going to go really, really, really slowly, but as it grows, it's getting closer to infinity. So by saying this, I can say S diverges by integral test. Again, we knew it was going to diverge. We just are using that for integral tests so we could see it. We okay?
Yes.
We good? Okay. You're not going to like this one. But here we go. We're going to do it anyway. Don't you love it when teachers say that? You're not going to like this problem. N times E to the negative n squared.
You were right. She's like, already. I just...
All right, so the first thing I'm going to do is say, I'm going to tell me that's S. Okay, I'm going to say your A sub n is equal to, can I write this as n over e to the n squared?
Yes.
That's your A sub n. So here's the thing, you've got an exponential in your denominator and a polynomial in your numerator, so you know that this is positive, continuous, positive, and decreasing, right? E to that power will never equal 0, so you'll never have a 0 in your denominator, okay? We good? Okay, so I'm going to say A sub n is this, and it is continuous, positive, and decreasing for all n's greater than or equal to 1. All right, so now I'm going to say A sub n is equal to f of x. So here we go. Let's set up our interval. I'm going to take the integral from 1 to infinity of x. I'm going to rewrite this right here with x's. Okay? So x e to the negative x squared dx. We need a u sub this. What do you think your u needs to be? Say it again. Negative x squared? Is that what you said? Okay, so let's set it up. U is equal to negative x squared. So then du negative 2x dx. So your x's will cancel and you'll have a correction constant of negative 1/2, right? If you divide through to solve for dx, you'd have negative 1/2. Okay, so here we go. I'm going to say this is equal to negative 1/2 times the limit as b goes to infinity of the integral from 1 to b of x, whoops, no, I need to use, I'm going to write this and then redo it with u sub, e to the negative x squared dx. Now I'm going to substitute that with u. Limit as b goes to infinity of 1 to b of e to the u du. Is that good? Because your x is canceled and we dealt with that negative 1/2. Okay, here we go. What's the integral of e to the u? Just e to the u, right? Okay, so I'm going to say negative 1/2 limit as b goes to infinity. Now put your function back in for u. Okay, so now I'm going to do e to the negative x squared. And I'm evaluating this from 1 to b. Okay? So far so good? Okay. So equals negative 1/2 times the limit as b goes to infinity. I can rewrite this as 1 over e to the x squared, right? Okay. So I'm going to put a b in for that x, but I'm going to rewrite it as 1 over e to the b squared minus 1 over what? 1 over e? To the first power? Okay. So it is negative 1/2 times what? What is this as b goes to infinity? 0 minus 1 over e. So what do we end up with? 1 over 2e? Positive 1 over 2e? Is that a finite number? Yeah. So what's that tell us? Yes, the series converges because you ended up with a finite number. Okay, so I'm going to say S converges by integral test.
Do you have to say like it converges to?
No, no, you do not. If it were FRQ and they asked you what it converges to, you could say that. You just don't have to. They typically they don't ask that.
Should that first 1/2 still be there? Because you were gonna.
No, I totally messed that up. Yeah, that should have waited on that one. Yeah, thank you. All right, I have 2 additional practice problems. I want y'all to work together with your group. Okay, here we go. And I want us to use integral test on both of these. Talk to each other about it.
Okay, well, I'm pretty sure
Whoops.
that it's continuous positively increasing because she told us integral test. Okay.
Hey,
Let's
Rachel.
start.
Here we go.
Hey, session.
Oh, we'll write on your hand for you later. It converges because it's not infinity. It's like a number. Squared over.
Ooh, n equals 0. That's weird.
Over n cubed.
Why did
I
I just
really
write
don't
that?
like doing this. Like these are just
I guess
not
we're supposed to start at n equals 0.
I thought all the time.
Alright.
I forgot all this stuff.
Yeah.
Equals S plus 1. Equals S. And then
So we have to
base
say
of
A
n
squared.
is equal to n squared over and then
That's continuous.
Okay. And because of that first 1/2, we need to start at 0 after. Make it worse if you. Okay. So, now what?
Over then
Oh, equals S.
4 n.
N equals n squared over n cubed.
Okay.
Base of n equals fx.
Oh yeah.
Integration.
From 0 to infinity.
Well, we have to.
not a, so it is a n.
So then we take the integral. No, 0.
0 to infinity.
Yeah, 0 to infinity
Of
n squared. Oh, x. Don't we need to do use of them? U equals the bottom. X cubed. Du
You're right.
x. squared. Oh, 3x squared, right? 3x squared times x. So that means dx equals 1/3. So then that means. So that means there's going to be a 1/3 on the outside.
Yeah.
Wait, no, then we can't plug that in there. We have to do the limit.
Wait, do we get rid of the integral?
We have to just
Of
integrate.
this.
C approaches infinity. 0 to 1. Yeah. Then we integrate it. So the 1/3 can be out.
Yeah, 1/3 times the limit of.
It would just be the x squared cancels out. It would just be 1.
Is it just ln?
Yeah, ln of x cubed plus 1.
Not even over here.
It's anyways ln cubed. And then so you just plug e back in.
Oh, yeah.
So it would be ln
So then what?
of x cubed.
From
Integral
0
of
to
1.
b.
And then you can plug in your values.
I'm confused. What if, wait. I'm confused again.
Well,
It's 1 over x cubed.
so we plug in b. So that's b cubed.
Isn't just 1/3 limit b from infinity there, 0 equals b? And then I put the u back in?
And then you do that.
Yeah.
Well, you integrate and then you have to do that.
Wait.
Oh, wait, no, it would
It's gonna be the limit anymore, or it's still being from the
Throw
limit?
that b into your f of b minus f of a. Once that b is in there, then you can drop
And
your
then
limit.
it would be 1/3 times the
What,
limit.
b
Is it just ln of g cubed plus 1 minus
ln of u.
1?
Would it be?
Yeah. ln
When
x.
did you drop it? Ln of
So then we can, well, because we have to finish our integration.
ln of the absolute
And then so we
value.
have our integration here, and then we take the limit of that integration, and that's when we can plug in our infinity.
So
That
then,
is not absolute
And then
value,
one of
or
these
that is not
values.
neutral.
so actually then it's just go 1/3. The limit
1/3 ln of infinity is infinity.
Infinity plus 1.
Infinity minus 0. I guess we have to.
I keep writing the wrong
b
letters.
cubed
Wait, where am I doing here?
minus.
I have a question. You drop the limit of these when you go.
Yeah,
Okay.
because you just took the limit. So you have your integral, which ended up as ln b cubed plus 1 minus ln of 1. So
Okay, I'm not
that's
sure how
only
good my
the
notation is.
integration,
Should
and
I?
then you still
1/3.
have to take the limit of it.
Jeez,
So once you take the limit, that's when you do it off. And then you have 1/3.
And 0.
Oh, therefore what
I got divergence.
ln of infinity
So would you get the first one?
minus minus 0, yeah.
Talk about it, or that she was
No,
struggling. with
infinity
tough.
cubed
The
is
limit
the
of
lock-in.
ln of 1, I think is
Come on, Ian.
So you write it as 1 over u.
the limit of
Because
ln of
the
1.
power rule won't
She's
work.
saying
And that's ln absolute value.
This thing be 0 because
Yeah.
it's a 0.
Can I like string these together, Miss Lee?
ln of
Like
0.
string this together?
It's the ln of 0 cubed plus 1.
I don't want to. It's so much work, Miss Lee.
No, just take the more paper, but.
I'm almost out of notebook. This is my
There's
second
an
one.
x cubed plus 1 that you put
Because
back in
you
for the u.
like 1/3 times the limit of the integral of 1 over u du, and then it would be 1/3 times the limit as b approaches infinity of,
ln of u.
which would be x cubed plus 1.
Or yes.
And then, here, do you just want to look at this?
So this diverges, right?
Oh, see, they said we're putting that in, I just put in straight up U,
Oh, it's
Diverges
it's tangent,
by-
right? Arctangent? Arctangent, yeah, okay.
Whoa. How do you like remember that?
It's been a
She
minute
said,
now.
do you recognize it? And I'm like, oh, wait.
Wait a minute. Okay.
A little light bulb.
That's not.
It has been a minute.
It's been a lot of
Think
minutes.
about what the graph of arctan looks like so that you can evaluate that limit.
Oh, it's just like
They're like, okay, since we've graphed arctan,
It's
it's been
like-
a long minute.
it's like
That's what
that.
even fatter than
Yeah, you know what it looks like, remember?
It's like
Yep, exactly.
it's
Yeah.
like x cubed but sideways.
Yeah, so
Okay.
cube root almost, right? But with
yeah, it goes
those,
like
yeah, yeah.
But with a bunch of asymptotes.
With the asymptotes, exactly.
Yeah.
Yeah, y'all know what it is. And remember we talked about there's like that restricted range.
We have an idea.
Not
we're
really.
just not
She's
sure
drawing
exactly
it.
where the asymptotes are.
Oh, yeah.
Yeah, it's where the asymptotes for tangent are, right?
Yeah.
Pi over
You just have to
Yeah, just
plug
the
it in. A lot of brain power.
Did you just write our?
Already taken.
N squared plus 1
Okay.
equals
I'm afraid I'm not gonna have enough room on my little foldy page here.
Well, we have the examples. These are just practice problems.
And I'm gonna have to like write.
and change equals
1 over squared plus 1.
When you finish these, there's only one integral test problem on that worksheet. It's problem number 11. You're not going to like it.
Again?
Forewarning you, you're not going to like it. Well, you're going to look at it and go, what do I do?
Only
But
what
it's,
I liked was
you'll figure it out.
the 1 over n. Everything else went downhill.
If we were 10, arctan negative 1,
Okay.
or 1, that would be where tangent equals
Okay.
1.
So then we have to write that.
And tangent equals 1.
Base of n.
I over 4. Yeah, I over 4.
How do you
That's
what's
two,
what's
basically, yeah.
arctan of what? Arctan of
That's
B?
greater than 1. Okay, yeah.
So this one's arctan of B minus arctan of
And
one. Wait, how do you know?
What?
Never choose arctan.
I know an arctan of one.
Oh, yeah.
Now do I drop? Okay, now I drop, right?
Doing arctan?
Yeah.
How do you know?
He said it's arctan.
Okay.
I
It's
mean,
We need to
I think
Theta, you're.
I
Okay,
can't
so now
do
we
that.
have
I
part
think
and
about
then we
this.
write this integral of.
So that's.
I don't know.
Yeah.
Hey, got it right.
1 to infinity of
So it's just
1
pi over
over
2
n
minus pi over
squared
is it?
plus
How?
1.
Maybe next
Do we have one more time?
Yes.
How do you do five or two?
I wanna know.
Miss Lee, could we theoretically just leave it as n or just write d
Two
n?
pi over
4
2.
pi over 8.
Or do we really, do we have to make it?
what's
six?
arctangent of infinity?
Yeah.
That is so that.
Like what?
Yeah, what is arctan of infinity?
Yeah.
Maybe
It's
we
like
have
if you
to
go to
say A
infinity,
and
your
then it's equal
chances
to
of
F of
F of
n
n.
pi over 2.
Yeah. Because it's the tangent as you
Good.
reach it.
I'm very much okay.
It's
Wait, why is
Just
arctan?
F with smiley face and just put smiley faces everywhere.
So what do y'all think about this one? Do you recognize that intergram?
Yeah. Rachel's like,
No.
yeah.
Alright guys, we did it.
It's the
Pi over 2 is why?
u squared
So
plus
that's-
1.
Oh.
I have to, yeah, it's a tangent, arctangent. Where's mine? It's mine. I figured it out. It's in my folder.
How are we doing on the second one?
Good.
This first one?
I don't really like arctan. You saw where would it be?
I've got the graph up here. So we'll
Inverse
have to
grid,
measure
here we
to
go.
infinity. What theta are we
U is
approaching?
just x.
number 20.
That's gonna be your
Yeah,
11.
no, it's just u squared plus
Today.
So you
Yeah, because I looked at 20 and I'm like,
yeah, 1 plus u squared.
What's the angle whose tangent?
So it's just pi over 2 minus pi over 4. No,
That's the formula.
Pi over 2.
For the arctan, it's 1
Over
over
one.
1 plus u squared plus 1. Or
Yeah.
1 plus
Infinity.
u.
Oh, so
So
it's-
our u is just x.
Infinity and
Okay, 2 pi over 4 minus
So,
2 minus 4.
What's the one in between those two?
Is it 1 pi over 4?
She said 11.
Yeah, right?
1
Yeah.
pi over
I'm thinking that's it.
Yeah.
So
I'm about to have
then-
all this space.
was pi
Yeah.
over 4.
This class is only worth it to tell people that I'm in this class.
Because you don't, it won't pass the credit.
Yes.
I mean, no, calc too low, but like it'll be good to have taken it, but it's also just gonna be worth.
It also
Yeah,
is like
okay.
probably will help you.
When you finish these two, go ahead and start number 11.
Yeah.
Tackle number 11 on your
No,
worksheet.
we have to write that it's,
I'll tell you what,
we have to put it.
Oh, that worksheet.
That might, I'll be actually an example.
I mean, honestly, I think I needed every little thing.
Positive decreasing what else?
Number 11.
So then you can just write it as the arctan.
Ugh.
X
Honestly, I almost just threw up in my mouth.
from
What?
1
That was so ugly.
Thank you for sharing this.
No, I mean, I was joking, but look at number 11, Ian. I don't want to do that.
Oh,
I'm scared now.
okay.
No, I
You're
was like,
scared?
I-
What are you
looked at-
scared for?
I haven't seen it, but they make it seem
Oh,
awful.
I'm trying to get two.
Number 11?
Yeah.
I mean, it's really not. I mean, you have to use U sub, and once you figure out what am I going to make U be, it's like, oh, well, that works out.
Yeah, it just looks
It's-
gross.
yeah.
Okay. So now,
Oh, I see. Never mind.
limit,
And 11 is?
or,
Oh, excellent.
and B.
Excuse
Minus
me.
R.
Integral from
And-
2
Excellent.
to 1 over x ln
Yes,
of
yes.
x.
Is that, who's Ellen?
So, Ms. Lee, on this